Today we're going to talk about vertical transformations with exponentials. So I can explain vertical transformations from the parent graph of an exponential. I can describe the vertical transformation that changed the graph f of x given the image and pre-image, label graphs, and I can explain the effect that changing a has on an exponential. So that is what we are going to be doing today. So let's get started here. We talked about transformations with linears when we talked about like the b value moving up or down. The parent function for a linear was y equals x, and we said if it was plus 1 at the end, then it moved up 1. If it was minus 2, it moved down 2. We talked about the slope being compared to 1, because that's the slope of the parent, right? We said if it was bigger than 1, then it was steeper, and if it was less than 1, it was less steep, right? So we talked about that. We talked about negative slopes flipping it. So those are the same kind of concepts we're going to be talking about today, but now in terms of exponentials. So transformations that moves graphs up or down on the axis is what we're doing. Y-axis, we're only doing vertical transformations. Horizontal transformations is something you guys will do in Algebra 2. So we're going to just get you started with vertical for now. That's all the EOC really focuses on. So we know an exponential is y equals ab to the x plus c. C is your asymptote. If c equals 0, a is your y-intercept. That's only if c equals 0. And b is your growth or decay factor, so what you're multiplying by each time. Yeah. Okay, it says growth there. I'll rewrite it in black. Can you see it in black now, Mackenzie?
Yeah.
Okay, just so other people can see it too. The parent function is specific to the base b value. Each base is a part of a family of functions. So for example, y equals 3 to the x is the parent of the family with base 3. The only things you can compare to this one here are anything with base 3. You may not compare anything else with this. It only can be compared if it has a base of 3. Only can compare exponentials with base 3. So your base, you have to look at the base. The base has to be the same in order to compare them. If they don't have the same base, you may not compare them. So the base is what the exponent is raised to. That's your growth or decay factor. So before we move on, what questions do you guys have for me? Right. Whenever you're ready, you guys can flip your slides. Just a reminder, midpoint is tomorrow, okay? Grades are due Monday. So if you guys want to get, retakes done, try to get them done by the end of this week. I'll be here before and after school tomorrow and before school on Friday. Obviously, you can do retakes after that time period, but if you want to get them in before the grades are due, do it then. All right, so let's do some examples. So let's first label the graphs on the graph. So f of x equals 2 to the x. Which one of those is f of x equals 2 to the x? And how do you know? Alexis, is it the dotted or solid line? Dotted. And how do you know that? This has an asymptote of 0, and this has an asymptote of 0. So that makes sense, right? So that makes the other one, what is it called, g of x? So we label this one g of x. And it has an asymptote of -3, and this one definitely has an asymptote of -3 as well, right? So you guys see how you can use the asymptotes to figure out which graph is which there? So first, the next thing it says is discuss the transformation that happens based on the parent graph. Name the family function. So we need to name the function that is the parent of this family. Who can tell me what they think the parent of this family is based on what I told you guys on the last slide? Katie? 2 to the x power, right? So we see that they both have a base of 2, which means that their family starts as 2 to the x. That's the most basic function with a base of 2. So our family function is y equals 2 to the x power. This is the one we'll compare to. So how does number 2 compare to that, transformation-wise? Isn't that just the parent function there? So this is the parent of the base 3. So this is the parent of base 2, sorry. So there's no changes there. How does g of x compare to the parent function? So here's the parent function. Here's g of x. What do you guys notice g of x is doing in comparison to the parent function? Anybody have an idea? Sarah?
It's just the same, but
It's lower by how many? So this one's by 3. This one's at 1, and it goes down 1, 2, 3, right? So it shifts down 3. This asymptote can tell you exactly how many it's going to shift down, right? So this is saying it shifts all y values down 3. That's the transformation that occurs. So 3 says discuss the domain and range. Iris, what's the domain of the first one there? Very good. And what's the range, Iris? 0 to infinity, asymptote up. This is not in context, so we don't have to worry about certain things being negative or not. They're just a problem you're doing, so you don't have to worry about making sure the domain and range makes sense in context. Spencer, what's the domain of g of x? Good, and what's the range? Of g of x, yes. Perfect. From the asymptote up. And then finally it says discuss the horizontal asymptote change. So in the parent function, would the asymptote change? Parent functions will always have their asymptote at 0, right? So we're looking at that. So the asymptote, it stays the same because it's the parent. Hannah, how does the asymptote change on g of x? Where does it go from what value to what value? Yeah. So the parent is y equals 0, and g of x is y equals -3, so it moves down 3. So questions so far on what we're going to be doing with transformations here? Questions so far on what we're going to be doing with transformations? Okay, go ahead and get that all copied, and then we'll move on to the next one. this should seem similar to lines. It's just an exponential. So the EOC loves to put transformations on there, mostly vertical transformations, so it's good for you guys to see this. You may go back, Alb. Are you good? Okay. So it says graph the functions and its transformation. So graph the function and its transformation on the graph. So first we're going to make a table. So -2, -1, 0, 1, and 2. So you guys can plug those into your calculators if you would like to. And then go ahead and make the table for g of x as well while you're at it. Go ahead and make your tables on your own. I'll put them up there in just a second. I want to see that you guys are trying them on your own. If you need a calculator, go grab one. And you can graph them yourself too if you want to. Alright, so I got my first table there. I have 1/4, 1/2, 1, 2, and 4. Does anybody not have those values for theirs? Okay, go ahead and get those plotted for me. So go ahead and plot that first function. And then we'll work on the next one. And then don't forget to label your graph as you graph it, so I'm labeling this one as f of x. And then I'm going to do my next table, and I get 1 and 1/4, 1 1/2, 2, 3, and 5. Did anybody not get those values? My asymptote is at 1, so I'll draw an asymptote at 1, and I'll plot my points. And then I'm going to have to relabel these because they're... So this one's g of x, and this one's f of x. Alright, so go ahead and get both of those graphed. So you're adding 1, so that's why the asymptote's up here. So you might want to move that. Go ahead and get that stuff copied down. When I see everybody's graphs are done, we'll continue. Yeah.
Graphs at points are the same for both. Like I have this, but then like -2, it would be 1 and then 2. And they're all the same.
But that's not your asymptote. You're adding 1. Your asymptote would be up 1. And you always go from 0. You always start at the, you don't start at the asymptote, you start at the axis. Okay? Be careful, it's +1. I've seen 3 of you put the asymptote at -1. Asymptote at -1 as well. It's +1. And then always plot from 0, 0. Okay? From there. Get both of them graphed on there. Both of these, okay? So is this one f of x?
Yeah.
So I would extend your line and then label it f of x and then get g of x lined. Albert, are you okay? Morgan, what is the parent of this family? The base of both of these is 2, so the most basic function is 2 to the x. So this is the parent right here, and this is the transformation. Remember, the most basic means there's no a value or no c value. So there's no a value or no asymptote value on it. It's just the base and its exponent, okay? They're stripped away of everything but the base and the exponent, and all the bases have to be the same. So then it asks you guys to discuss the vertical transformation that happened based on the parent graph and discuss the transformation of the 2 graphs. So this is the parent graph. So we're not going to discuss a transformation here. So this is the parent. So we don't need to worry about that here. But we do need to worry about here. What happens? What transformation is occurring? Can somebody tell me what they see? Jenny? The asymptote is 1. Good. But what does that mean in terms of the parent? How is that transformed compared to the parent? That's what we're looking at. We're comparing it to something else. Hannah? Shifts the y values up 1, and what does it do with the asymptote as well? Shifts it up. So all things are being shifted up 1, aren't they? Can you even see that in your tables that you made? Look at this. 1/4 plus 1 is 1 1/4. 1/2 plus 1 is 1 1/2. 1 plus 1 is 2. 2 plus 1 is 3. 4 plus 1 is... You can see it in your tables as well. So it shifts all y values and the asymptote up 1 from the parent. Carly, what's my domain of the first one there, f of x? Good, and what's my range? 0 what?
Infinity.
Good. We don't go below our asymptote there. Kelly, what's my domain of number 4? G of x. Or not number 4, G of x, sorry. Good, it goes forever in both directions. And what's my range? Kelly again. It's the black one up here.
0.
So this is 0 here. Does it go below this line here? Is there anything below this line here that's black? No. So what is this line here at?
0.
No. This is 0.
What?
This is the origin right here.
Oh, it's
0,
a
0.
normal line, then that one is 1.
1, right, because you have your asymptote at 1. So it starts at 1 and goes up forever. Very good. All right, what questions do you guys have about that one before we move on? All right, then go ahead and flip to the next slide. All right, start making your tables for the next slide, please. Get those both graphed on the same graph. Go ahead and start making your tables, and we can start making those graphs. So start your tables for both and get them graphed. Don't forget to draw in your asymptotes. So my asymptote for the first one is at 0. I'll plot my points. And I'm going to label my graph as well. If you are not getting the same points that you see in my tables, please let me know so I can help you. All right, so go ahead and get those graphed. I'm going to walk around and make sure you guys are on the same page. Make sure you're getting the asymptotes on your graph as well. If you do not know how to graph, please let me know. This is something you guys learned last week, so that's why I'm not really talking you through it. I'm kind of letting you guys do it so that you guys can figure it out on your own. If you need me, obviously let me know. Please draw your asymptotes in. Make sure you're doing the tables on your own. Make sure you're drawing your tables in too. All right, guys, what is the parent of this one? We've already labeled them. What is the parent of this function here? Who can tell me the parent? Alex? Say it like as an equation all the way.
Oh, that's the x.
1/3 to the x. So you see that both of them have a base of 1/3. So the most basic is it means there's nothing multiplied out front and nothing added at the end. Very good, Alex. Okay. So this one here is the parent. So we don't have to worry about this one. But we do have to worry about the transformation for this one here, the second one, g of x. Kaylin, what transformation do you see occurring in g of x?
And the asymptote is 5, and it's just what values up.
Everything is shifted up 5, right? The asymptote is shifted up 5, and the y values are shifted up 5. Very good. And that's because of this plus 5. And you can see that in your chart again. 9 plus 5 is 14. 3 plus 5 is 8. 1 plus 5 is 6. So, all y values and the asymptote shift up 5. Sarah, what's the domain of f of x? What's the range? Very good. Jacqueline, domain of g of x. And what's the range? Good. Okay, what questions you guys have on this one before we move on to the next one? Got to get through all of these notes still, so we have 11 minutes. so let's look at the next one here. Right, graph the function and its parent. So before we do that, what is the parent of this function? Can somebody tell me what the parent of this function would be? F of x equals 2 times 3 to the x. Mackenzie? Y equals 3 to the x. So if I make a table for y equals 3 to the x, I'm just going to do -1, 0, and 1 just to make it a little bit quicker here. So that's 1/3, 1, and 3 with an asymptote at 0. You guys can just copy my table this time. You don't need to figure it out yourself. I'm going to label this y. This one I'm going to do the same thing, -1, 0, and 1. So that's 2/3, 2, and 6. So same asymptote. Okay, so go ahead and get those graphed for me. And we'll talk about what's happening in this one. Please copy down the tables if you have not done so. If you have not copied down the tables are important too to see what is happening with the transformations as well. That's why I have them written on my slides, and I would like you to have them written on yours. So this is the parent. Before we talk about the y-intercept, we're going to compare. What do you notice from the parent, so from the green one to the purple one? What is happening with all the y values? They're being what? Yeah.
Multiplied by 2.
Yeah, so the asymptote remains the same, but all the y values are being multiplied by 2. You can see that. 1/3 times 2 is 2/3. 1 times 2 is 2. 3 times 2 is 6. Where do you think that 2 came from? Where did that 2 come from? Yeah. From that a value. Very good. So the asymptote remains the same. But y values are multiplied by 2. What is the y-intercept of the purple one? So this is the y-intercept of f of x. What is the y-intercept of it? Jenny? 0, 2. Very good. Where do you think that number came from, guys? Where did the y-intercept come from? That 2 value in the front. Comes from right there. All right. Go ahead and flip to the next slide when you're ready. Or at least be able to get through this one. If we can do the last slide, we can do the last slide. Otherwise, you have problems like that on your homework, you can try them and we'll go over it on Friday a little bit more. Questions so far? Is this making sense to you guys, like why things are happening? The asymptote shifts it up and down, the value up front multiplies it. So that's kind of why this happens the way it does. So graph the function and its parent. Again, I'm going to do what is the parent of this one? Who can tell me the parent of this function here? 1/2 to the x, but you have to write it as an equation. Don't just say 1/2. So it's 1/2. So if I make a table of values, again, I'm just going to do -1, 0, and 1. I get 2, 1, 1/2 with the asymptote at 0. Then I'll do my table here, and what you'll notice, I'll get -2, -1, and -1/2. My asymptote's going to be the same. Again, write the tables and go ahead and copy the graphs. What is the transformation that happened here? Jenny? Why do you think it flipped?
Because the asymptote's negative 1/2, but in front of it's negative.
The negative makes it flip, so the asymptote stays the same, but the negative out front makes it flip. Just like the graph, when you have a negative slope, doesn't it flip from a positive to a negative? So that same concept. So what is my y-intercept? Vivian, what's the y-intercept of f of x? Well, we write that as an ordered pair, 0, -1, which makes sense because this is -1 out front. Kelly Kavanaugh, what is the domain? It still goes left to right forever, but the range is going to change. Who thinks they know what the answer for the range is? You've had problems like this on your homework, yeah. So the lowest down value is -infinity, right? Because it's going down forever, but it only goes up until 0. So it kind of switches that because it's not going above the 0 this time. You always go least to greatest. All right, sorry about all that. I will look at your homework. Try the problems that look like the last slide, and you can obviously